Okay, in this question, it has 4 parts, and they're all about finding partial derivatives, and even first order in, I think, all of them. Yeah. Notice immediately, on purpose, I wrote them in different ways. Like here, partial of h with respect to x, this is exactly h sub x. We can write it this way. And this u sub x also, it could have been written as partial of u with respect to x. Also, this, you just learn to write it in both ways. This is partial u with respect to y. This is h sub y. You'd ask, why do you have two notation for the same thing? It's because they are useful for different situations. This, if you understand more math and higher math, like this, what you're using now, but understand more about vectors and so on, then you will know why we use both notation in different cases. But for you, just know that either of them could be given of the two notation, and you need to know that they mean the same thing. Find the derivative with respect to x in this way and with respect to y in this way. That's good to agree on from the beginning. So let's start. In this first one, we have the function f is a function of two variables, x and y. So we would say that in this case, the independent variables are x and y. These are the independent variables, and f is the dependent variable. Or sometimes, we use z instead. Z of x, y equal this, and then you say z is the dependent and x, y are independent. Because they're independent, when you're taking derivatives, you consider each of them as constant with respect to the other one. So let me start. So the function is something raised to the power 4. This power is for everything inside. So the thing inside, let's call it heart. And so in this case, we know from the chain rule that the partial with respect to x of the function, if you write it as heart to the power 4, so the entire thing, it means this is heart to the power 4. The derivative of this is 4 comes down, then you subtract 1 from 4, you get 3. This is the power rule, but because heart also depends on x, you need to take the derivative. That's the chain rule. So derivative with respect to x. If, I will tell you another thing, if this here, and let's choose another color. If this was the derivative with respect to y, then the entire thing will be the same. You'll use the power rule to get this part, and then instead of x, you'll put y. So you'll take the derivative with respect to the one they're asking you for. If you're asking for with respect to x, then here you take heart with respect to x. If you're asking with respect to y, then you take heart with respect to y. Just keep this in mind. So, yeah, let's go back and just evaluate and finish this part, because this is actually a very simple question. So now this will be 4, and now heart, we called this heart, the stuff here. So it's x cubed plus 3xy minus 2y squared, that's heart, to the power 3. You see, 4, we wrote it here, 4. Heart to the power 3 is here, heart to the power 3. I shouldn't do all of this, but I'm just showing you that I'm not bringing this from nothing, times. Now this, heart x. So the derivative of heart with respect to x, this is now important. This is heart sub x. I will replace it once we know it. So heart, remember, is x cubed plus 3xy minus 2y squared. So heart with respect to x, the partial of heart with respect to x, or the derivative of heart with respect to x, is 3x squared, of course, the derivative of the first, plus the derivative of this, but with respect to x. If it was, for example, suppose instead of this, it was 3x, and instead of y, just consider it as a constant, put 2. So this will be 3 times 2, 6x. And if I tell you, take the derivative, you'll tell me 6, with respect to x, of course. So if instead of the 2 you put y, it doesn't matter. It will tell you that this will be 3y as the constant times x. So if you take the derivative with respect to x, then you'll just get the constant, 3y. That's why here the derivative with respect to x is 3y. If I ask you the same one but with respect to y, what would this with respect to y be? 3x. This if you take with respect to y. With respect to y. And this with respect to y is 0. And this with respect to y is 4y. The derivative. You see, very easy to do with respect to the variable they give you. But when they're mixed in the same formula, they're multiplied or something, then it becomes, you need to concentrate. So now notice that, just take this, there was a minus, but this now has no x's. Because it has no x's, the derivative will be minus 0. It has no x's in it. And the function heart was a function of both x and y. And so if the formula that you're deriving does not have an x, then it's like a constant. For you, this is x sees this as a constant. It doesn't see it as anything else. I mean, it sees it as minus 2y squared or minus 8. What it does is that it sees it as a constant with respect to x. When we say with respect to y, you do the opposite thinking, if you know what I mean. Okay, so I don't want to spend so much time on this, but just remember all these ideas. That this now will mean that this is just 3x squared plus 3y. And we're done. So we will put this back here. So I'll take it from here and replace 3x squared plus 3y. And now, since this was already recorded, you can play it back. But okay, I want to erase so that I have space to continue writing things. So okay, for now it looks like a nice question. How do we check? So now this is nice as the answer to f sub x, but they're asking us to evaluate it at a point. So they're telling you now take -1 for x and 2 for y. Let me use a different color even for y. Let's use the blue for y. And replace them back in the formula. So that's the first thing you do is find it in general. Then now fx, you can say even therefore, so people understand that you computed something ahead of time that gave you this. You say therefore, because of my computation here, this one, I can conclude that the partial derivative of f with respect to x at the point -1, 2 is 4, and then now substitute things, cube times, substitute things here. So this is 3x squared plus 3y. This one is x cube plus 3xy minus 2y squared. Whoa, it's big. y squared, and then all of it cube, all of this thing. So because I want a different parentheses, different color, so I remember that there is a 3 outside all of them. Okay, so now replace minus 1, we say x in red, minus 1 for x, so you'll put it here, minus 1. I know that it's here and here, so 3, then minus 1 here, and there is an x there, so a minus 1 here, and then for y it's the blue, so y we put 2, so here 1, 2, 3 y. So anyways, the leftover is a y. And just compute this. So this is 4, and then something cube, and now let's at least do this one. Negative 1 squared, this is 1, times 3 is 3. Together these are 3, plus 3 times 2 is 6. 3 plus 6 is 9. And here minus 1 cube is minus 1. 3 minus 1 times 2 is negative 6. And then minus 2 times 4 is 8. Because you have 2 squared, this gives me a 4, and then times the 2 gives me the 8. Okay, so this will be 4 times 9 now. I can continue here. It's 36 times minus 1 minus 6 is negative 7, minus 8 minus 15 to the power 3. So I can even write it like this. This minus 15 cube is minus 1 cube times 15 cube. And this is minus 1 cube is minus 1 times minus 1 times minus 1. These two together gives me 1, and then there is another minus 1. So minus 1 is the answer to this. And this is 15 cube. So the minus comes outside, 36 times 15 cube. Just wanted to tell you that the minus can come outside. I spent so much time to just show you this. So anyways, let's see how much this will be. Make the calculator just smaller and see. Minus 36 times 15 to the power 3 equals, so negative 121,500. This here, the answer that we got in the calculator, is the answer for what? The derivative of f with respect to x at this point. So it's negative. This means that if you fix y and consider x as moving, this means that it's decreasing. The function is decreasing in x if you hold the y constant. Anyways, we know that when the derivative is negative, your function is decreasing, and when it's positive, when the derivative is positive, then the function is increasing. Okay, so in any case, this is done. I just want to show you something nice, is that you can actually use the calculator to just check that your answer is correct, at least for the beginning. The derivative of this, you want it with respect to x. So look in the calculator what I can do. I can say d by dx and put the formula. So the formula says what? Here I'll put x cubed. So here is the x to the power 3. Actually, I will have to put power 4 outside. So I will put parentheses. Look what I will do now. I'll put parentheses to the power 4 and then go back and fix the formula. I mean, continue this formula now. Plus 3xy. You see, I'm almost there. Plus 3xy. Now minus 2y squared. Minus 2y squared. And look at the answer now. Is it the same? This answer that you see here, is it the same as the answer we got here? Let's see together. 4 is there. 3y plus 3x squared is there. Yes. And this is yes. And then x cubed plus 3xy minus 2y squared to the power 3. Yes. So it is exactly the same. So they're equal with a happy face that we got it right. And now the substitution of x negative 1 and y 2, we did it on the calculator, so it is correct. So now we can erase this and start the second question. And now we will move faster, because the first question we were talking about the notation and things that we should agree on before we start, and that's why now we can move faster. Here they want us to find the derivative of g with respect to x and the derivative of g with respect to y. We have to do both of them, where g is this function. Now pay careful attention. To take the derivative with respect to x, what do? We first look at this one. This is x raised to a power. The power is y. Okay, don't worry about it. If the power was 3, and I ask you find the derivative gx, what would you have said? 3x squared. So, because it's a power function. But if you have, instead of 3, y, what will happen is that when you take the derivative of this with respect to x, the y will come down and then subtract 1 from the y. Because you're taking derivative with respect to x, and with respect to x, this is a regular power function. It's not an exponential function. So the derivative is just the power rule. Bring the power down and subtract 1 from the power. Good. So this is the first thing, is that the derivative of this with respect to x is y x to the y minus 1 plus, and now we do with another color better, this one with respect, remember, to x. We want with respect to x. So y is a constant, like number 2, it stays the same. Y is a constant multiplied by it, so it stays the same. And e to the x, the derivative of exponential e specifically with base e to the x is the same, e to the x. If it was 2 to the x, remember, if your function was 2 to the x, then what is the derivative? The derivative is the same, but you multiply by ln 2. So if you have 5 to the x, what is the derivative? It's the same, then times ln 5. That's why e to the x is the easiest one of them, because the derivative will be e to the x times ln e. But ln e is 1, and so the entire thing is just e to the x. It's the only exponential function whose derivative is exactly the same, without multiplying by anything. Okay, so nice to remember this, so that now you see why we have the answer that we have. And so let's write the entire answer now in one shot. So g sub x, so that's the partial of g with respect to x, which can be written like this, is y x to the y minus 1 plus y e to the x. Notice you can take y as a common factor, but I'm not going to. Just keep it like this. If you need to simplify further, you understand how to do it. So now the partial of g with respect to y, you will now look again, but think differently. You will think now in terms of y, the eyes of y. When y looks at this, it sees it as an exponential function with respect to y, because y is the one in the exponent. Because y is the one that is in the exponent, this is an exponential function. Okay, just like if it was, this is the function x to the power y, but it could have been 2 to the power y, in which the derivative with respect to y will be 2 to the y ln 2. So x to the y, it will be the same, x to the y, but ln x. That is with respect to y. So x to the power y with respect to y, the derivative is the same because it's an exponential function. So it's x to the y times ln of the constant here is x. Because when you take derivative with respect to y, it thinks of x as a constant, just like number 1 or number 2. Okay, and so that is the beginning. And now the second part, let's do it in orange. This part with respect to y. This is very easy. With respect to y, it's y multiplied by a constant. This e to the x is like a constant, like number 3. If you had y times 3, this is like 3y. And so if I ask you find the derivative of 3y, so find the derivative with respect to y itself, you'll just give me the constant, 3. If it was ky, the derivative is k. So if it's e to the x times y, the derivative is just e to the x. It's just the constant that's multiplied by y. And so that will be it. And I will write it in another color. Let's do it all in, not even green. Let's use a color we didn't use so that we focus now when I'm checking. Gy, we found that it's x to the y ln x plus e to the x. Okay, and the other one for g sub x was this. Now, remember that g was this function. I'm just reminding you so that now we enter them in the calculator and check that we got the right answers. So now, get the calculator, put it here, and let's enter the functions. Actually, I prefer the calculator to be here and to be smaller. Okay, so now first enter the function in the calculator, and remember we will take with respect to x and with respect to y, so it doesn't matter which one you start with. I'll start with x. So d by dx of, and now I'll put the g. G is here. X to the y, so get the x here, to the power y, nice, and then continue, plus y e to the power x. That's with respect to x. Let's compare it to what we have here and see if it's the same or not. Compare this to the answer there. X to the y minus 1 times y. This I see it there. And then e to the x, y here, y e to the x. Yes, happy face. Okay, so the first one is correct. Okay, and then let's just, and then now highlight the second one and check that it's correct. Now you'd say, how do I change? Nothing to change. G stays the same inside, but you want with respect, not x, delete this and put y, with respect to y, and check the answer. So is it x to the y? Okay, so is x to the y ln x there? Yes. Compare, yeah? And plus e to the x? Yes. Big happy face. Yes. I'm really happy that we can check our answer. So always if you can get the calculator to check your answers while studying, then you can write any function down and take its derivative, then check. You can always do this. So it's nice. Now, we will now go on a faster rate for C and D. So in C, I want you to notice that the function here, we want to do the same thing. Find its partial with respect to x and its partial with respect to y. But before you start, since you see a logarithm, notice I told you always, whenever you see logarithm, look at the inside of it and see, can I simplify it ahead of time so that I answer an easier question, or it's as simple as it can be. We see that no, there is a square root inside. This square root is just power half and we can bring it outside. So you can say that this h of xy is equal to y ln, and then inside the ln I have x plus 2y under the square root, so it means power half. And so this power half, because of properties of logarithm, this power half comes down here. Okay, and so what would you get? So you'll get half y ln of the rest, x plus 2y, the thing without the power. So the power came down by the property of logarithm. Nice. So now you can just focus, forget h being this function, and look at the easier form of h. So what is the price we had to pay? Instead of having a square root, imagine the price that we had to pay was just multiplication by half. Something very simple to trade in for getting rid of a square root. So now, therefore, you will now focus on this and take its derivative with respect to x, then with respect to y. So first we'll do with respect to x. Let's do it in green. H sub x, that's the partial of h with respect to x, this one that they're asking us to find. Just a different notation, I'm writing it like this. So it is half y, that's a constant. And then now, logarithm, the derivative, remember, derivative of logarithm is the derivative of the inside of the logarithm with respect to x. That will be 1. You see, x plus 2y. Derivative with respect to x, 1. And divided by the entire thing without the log, or within the log. So I will remind you of this. If you have ln of heart, and someone asks you, find the derivative with respect to x, then it just becomes put heart in the denominator and then here take its derivative with respect to x. Or if they ask you with respect to y, take the derivative of ln of anything, that's why I'm calling it heart, then heart in the denominator, and here it's the derivative but with respect to what they're asking you. If they ask for x, you take x. Y, you take derivative with respect to y. Good. So now that is what we did in here for x. So that becomes y over 2 into x plus 2y. Very nice and compact formula. This is h sub x. Let's do h sub y in a different color. So now, but for y, notice something. Y appears here outside the log and inside the log. So in this case, I will just, in this box, I will write something very important. H of xy, we can see it as heart times diamond, where the heart is half y, that's what I'm calling heart, and diamond is the ln of x plus 2y. Okay for this? So I'm just giving a name to each one. Heart is half y and diamond is ln. So if I tell you now, take the derivative with respect to y, you will apply the product rule because both of them have a y. For x, we didn't need to do this because this one has no x's and it was a constant. So there was no need to apply the product rule. But here, we need to apply it. And so the derivative, you remember the product rule is 4 things. So how about I do it down here, like without borders. Let's just keep the border just here and now say this implies that here. Yeah, if you have heart times diamond and someone tells you take the derivative of this with respect to y, then it's 4 things. And so the first thing is heart y derivative times the diamond plus the heart as it is times the derivative of the diamond. This is the product rule. And notice that this is with respect to y. Because if you had instead with respect to x, you would have done heart x and diamond x here. Yeah? Nice. Okay. So now you'll come here and say heart with respect to y is half, just half. So that's half times diamond is ln x plus 2y plus heart is half y times diamond y. Diamond y is the derivative of this with respect to y. If you have ln x plus 2y and I ask you take its derivative with respect to y. Remember, log is one of the easiest things to take its derivative. Just copy it in the denominator, what you have inside, and then in the numerator, take the derivative of the inside with respect to, in this case, y, because they asked us y. So derivative of this with respect to y is 0 plus 2 times y, 2. So it will be 2, the derivative. Okay? Because derivative of y, of x with respect to y is 0, and 2y with respect to y is 2. So this whole thing will be just 2. And finally, you will put this here where it belongs, 2 over x plus 2y. Alright, now I will erase so that I can write the final answers, and we check on the calculator so that we finish this last problem after. There is just one problem after this. And so let's continue here. So equals. You can put the half, you see, the half ln. Put the half back as a power and it will give you the square root again. Because now you are done. You just want to write things in an easier way. Plus, here, which one now? Yeah, half, the 2 goes with the 2 down, and so you just have y over x plus 2y. In fact, I would like to just say it like this: h sub y, which is the partial of h with respect to y, equals this. Just to look better, I'll put the equal between them. Okay, like this. And so I have two things that I will highlight now. First, this becomes 5 and put them here. So h sub x is this, the blue, and h sub, let's do a green, h sub y is here. Let's check with our calculator. First, remember what was h? H was the thing that you have here. So this is, put it in the calculator. That's what I'm doing right now. Please watch careful, and always, if you have a calculator that can do it, even I suggest just get this calculator. I told you from the beginning of the semester, for 11 dirhams, it's the same price. This calculator is for 10.99 AED. So 11 dirhams, the same price as the smallest cup of coffee from Starbucks. But this calculator stays with you forever. So in any case, let's enter it. So first we want the derivative with respect to x of, now enter this function. Now I will be putting this formula inside. Y, okay, so where is the y? No, y didn't come, just one second. Alpha, this, yeah, y, ln, radical, x plus 2y. So x plus 2y, and close the parentheses like this. Yeah. So is this the answer that we got for x? So let me just remind you. For h sub x, we got this as the answer. Y over, so y, yes, over 2 times x plus 2y. Correct. Very nice. I just will keep it so you can see. This is the correct answer. And for y, we'll go back, instead of x, with respect to x, we'll put with respect to y. And now let's see. Yes. By the way, if you want to remember, this is the square root. I put it back on, but you can leave it outside. You can say half ln 2y plus x, or x plus 2y, doesn't matter, plus y over, and look at this, x plus 2y. You can write it as 2y plus x. It doesn't matter. Addition is commutative. So, great. It means that we got everything correctly, and we can go to the last one in this question. So question 7 had parts A, B, C, and D, and now we will do D and finish. Great. So let's see here. Similarly, we have a function of two variables, and we need to find its first order partial derivatives. So let's start. One thing is here, when you have x over y, I want to teach you something nice. If you have within your formula something like this, you can say, I can simplify things for derivatives easier. So this is e to the xy plus, look at how I would write it, x times y to the power negative 1, yeah, minus 3. Now let us start taking derivative. Derivative with respect to x of this function, let's see. Derivative of exponential is the same. Always write it the same. So I'll use another color. It's the same times the derivative of this, but with respect to x. The derivative of xy with respect to x is just y, because y is like a constant. If I tell you what's the derivative of 2x, you would tell me 2. What's the derivative of minus x? You'll tell me minus 1. What's the derivative of yx? You'll say y. because I'm doing with respect to x. Okay, and the opposite when you're doing with respect to y. You think of x as constant. Plus, now we're done with this. Now here, with respect to x, remember? So it's x multiplied by a constant. This is for you is a constant, so just stays as it is, minus 0. So let me write it better now. It's y e to the xy plus 1 over y. You can actually write it in this way, and that will be our partial of u with respect to x. Beautiful. Now, partial of u with respect to y. Let's do the same thing, but now think of y as the thing to take derivative with respect to. So here, it's almost the same as what we did before. Exponential stays the same, but then you multiply by the derivative of this with respect to y. With respect to y, it's x plus. So now we are in the second one, but with respect to y, x is a constant, leave it as it is, but y has power -1, so x stays, but y, the negative comes down, and then you subtract 1 from the power, so it becomes -2 minus 0. So the derivative of this with respect to y is 0. Any constant with respect to any variable, the derivative is 0. So now this becomes x e to the xy minus, this will be x over y squared. Also, you can take x as a common factor if you notice here. And then you have e to the xy minus 1 over y squared. So it can be given in either one of these equivalent forms. Okay, so this will be our uy, and I will just highlight so that we use the calculator to check this one, and let's highlight with this color for uy. So I'll highlight this, and also, and keep an eye on this. It might be that they take x as a common factor, but the calculator I have has not been taking common factors so far, so that's why I'm giving you the answer that doesn't have common factor. Okay, but they are the same, of course. Now, our function, remember, is here. So, and I need to take its derivatives. So I will first say I want the derivative, and now I write the function. So it's e to the power xy, and then plus x over y, and then minus 3. This minus 3 doesn't matter if you put it or not. So check. Where would you check? You need to look at this now. Is it the same? Y e to the xy plus 1 over y? Yes. With a happy face. So this is correct. And now the second one. Here just change with respect to x. Make it with respect to y. And see. They took a common factor. So let's compare it to this. I'll put this now in pink. This one is our answer. Compare it now to the calculator and see. X outside, yeah. Inside we have e to the xy minus 1 over y squared. Yes. Big happy face, and we're done.